Good afternoon, everyone. My name is Dustin Bracey. I'm here with my partner Tazib. We're data scientists from SMU, and we're here to give you a quick case study in beer. Alright, so we're going to utilize R to quickly study craft brew and breweries. We've got a data set of about 2,400 different beers and over 500 different breweries. We're going to look at that, quickly visualize it, and see if we can get some strategic opportunities or get some insights that might provide a competitive advantage for Budweiser and its partners in the United States air operations. Alright, so let's get into it. So Colorado right here leading the pack, the brightest color up here on this heat map with 47 breweries in the state. You've got some of those darker areas, DC, the Dakotas, and West Virginia. They might be good opportunities to expand our market share and open up some new breweries. Alright, let's talk a little bit about the data itself. So the data is a great data set. We're missing 5 styles out of 2,400 different values, which is awesome. 3 out of 5 of those are also missing ABV and IBU, so we just pull those out of the data set and move on with our analysis. ABV is missing about between 2 and 3% of values, 62 to be exact. That's enough that we can do maybe do some imputation, do some machine learning, try to figure out what is a reasonable value for ABV given the other information about that beer. IBU is going to give us some trouble. We're missing about 40%, over 1,000 data points from the data set, and that is going to be hard to predict. I've got a slide up here that will show you just what I'm talking about when we try to impute it. So when we impute ABV, this is a sample of about 100 different styles, only 15 up here for you to see, so it's not such an eye chart. Cream ale looks great, right in the middle, and that's what we want. So American Strong Ale is a little bit of an outlier, but if you look at the data set as a whole, there's not a lot of outliers, not a lot of eyebrow raisers. But when you get to IBU, you see something like cider where there's not a single original value for IBU, and we're just kind of making a straight guess. The software is looking at ABV, it's looking at the brewery, it's looking at the ounces of the fluid ounces of the beer, and it's saying, okay, what is my best guess using linear regression? You get some values in there that maybe make sense and maybe don't. So we're going to utilize empirical evidence, what's labeled, and we're going to move forward with our analysis and taking out all of the non-labeled IBU information, which still gives us over 1,000 different beers to look at. So some summary statistics. Maine's coming out on top. Median ABV is the highest there. Arkansas and Utah are probably the lowest here, about 4%, with Maine coming in at 6.7. Maine again coming in high on the median IBU. And this time you've got Wisconsin at the lowest. So this tells me if we're looking to sell beer in Maine, we need to make maybe an IPA or a double IPA, make something that's real bitter and real strong, and I think we'll have a great success with that. Here's some of our trend leading beers. The most bitter and the highest ABV, to be exact, 12.8 coming out of Boulder, Colorado, 138 IBUs coming out of Astoria, Oregon. And then this is some summary statistics on ABV itself. So you can see it's a little right skewed. That brings our mean a little higher from 5.6 median to 5.98 mean. Our interquartile range is 1.7. That tells us that 50% of the alcohol or the beers only vary in alcohol by 1.7%. Now, we look at alcohol by volume, and we look at the fluid ounces of these beers. We see some interesting. You see these little slivers there for 8.4 and 16.9. That tells me that there's only maybe a handful of beers that have those, that come in those fluid ounces, and they look to be very strong beers. So you get the normal 12-ounce can, looks like it's a lowest alcohol by volume median. And then let's look at, is it IBU related to ABV? Pearson's R is a statistic that tells us about correlation. When we square it, we get the explanation of that. So 45% of the variation in ABV is explained by IBU. And that's statistically significant evidence, a p-value of less than 0.001, that the ABV and IBU are linearly correlated. Now, so that's just kind of a general trend. 55% of the other factors cannot explain the alcohol by volume, and those aren't plotted here, and we didn't actually look at that in our short time with this data. All right, so let's look at some hot spots, some trends. Top 10 cities, we looked at the most breweries per state, but these are the most breweries per city. Grand Rapids is coming out on top, 66 different breweries just in Grand Rapids, Michigan alone. San Francisco is coming in with 32, it looks like. And then if we look at the number of beers that are coming out of those breweries, Grand Rapids is coming out on top again. 62 different beers, unique beers coming out of that one brewery, which is incredible. So Bonfire Brewing in Colorado and Suntan Brewing in Arizona are coming in tied for 9th there at 19 different beers coming out of their breweries. In summary, we talked about where the beer and the breweries are located. We talked about notable beers, the trendsetters in the market. We looked at the IBU and ABV and whether or not they're related. We had actually built a machine learning algorithm that I don't have a slide for that classifies beers as an IPA or not using only ABV and IBU. And that model is actually about 78% accurate. So 78% of the time it correctly predicts whether the beer is an IPA or not, just using ABV and IBU and nothing else. And then we looked at some market trends. We looked at the hot spots, the hot cities, the hot breweries, where we're going to make maybe the most impact for our beers is coming out of. So in summary, that's it. I didn't want to take a lot of your time, but I've been Dustin Bracey. You've been a great audience, and I look forward to our next one. Thank you.